Hi everyone, I am Dr. P. Kalpana. Welcome to my channel. In this video, I will explain the concept of linear differential equation. First, I will explain what is a linear differential equations, then what is a difference operator, and how to find the solution of a linear differential equations. So first coming to the linear differential equation. So linear differential equations or equations in which the dependent variable and its derivatives occur only in the first degree and they are not multiplied together. So the general form of a linear differential equation is dny by dx power n plus p into dn minus 1 y by dx power n minus 1 plus p2 d n minus 2 y plus d x power n minus 2 and so on plus y equals to q. So this is the general form of a linear differential equations. Here y is the dependent variable, it depends on x, and from the definition of the linear differential equation, so the differential equation and its derivatives are in the first degree, and this is the order. Dny by dx power n is the order is n here, and if you see the degree is 1. So generally the linear differential equations are occur in only the first degree, and the derivatives in the dependent variable is not multiplied together. So here the dependent variable and its derivatives are not multiplied. So this is the form of a linear differential equation. To find the solution of a linear differential equations, the complete solution equals to complementary function plus particular integral. CF means complementary function. And this is particular integral. So to find the complete solution of a linear differential equation, you should know how to find the complementary function and how to find the particular integral. And another important term is difference operator. So that is d by dx or d square by dx square and d cube by dx cube. So this can be denoted with a symbol d square, d cube. So this is the difference operator, just the derivative is written as the d. So d square and the d cube. Now I will tell you how to find the complementary function. So the rules for finding the complementary function are: first, write the linear differential equation in the symbolic form. So that is in terms of difference operator. So this can be written as d power n y plus p1 into d power n minus 1 y plus p2 d power n minus 2 into y plus so on plus y equals to 0. So this is the symbolic form. So that is the first step. And the second step is write its auxiliary equation. So just d power n plus p1 d power n minus 1 plus p2 d power n minus 2 plus so on plus 1 equals to 0. So this is the auxiliary equation. So first write down the linear differential equation in the symbolic form, and the second step is write its auxiliary equation. Just removing the y term, and that is equating to 0. So that is the next step, and then find the roots of the equation. So there are some cases. The case 1 is if the roots are real, case 1. If the roots are real and not equal, then the complementary function is C1 e power m1x plus C2 e power m2x, where m1 and m2 are the roots of the equation, auxiliary equation. And now coming to the case 2. If the roots are real and equal, then its complementary function is C1 x plus C2 e power m1 x, where m1 equals to m2. The roots are real and equal, then the complementary function is C1x plus C2 e power m1x. And case 3. Case 3 is if roots are imaginary and not equal. So one root is alpha plus I beta and another root is alpha minus I beta. Then the complementary function is e power alpha x C1 cos beta x plus C2 sin beta x. Case 3. So case 4. Case 4 is if the imaginary roots are equal. So m1 equals to m2 equals to alpha plus I beta and m3 equals to m4 equals to alpha minus I beta. Then the complementary function is e power alpha x C1x plus C2 cos beta x C3x plus C4 sin beta x. So these are the 4 cases which are useful to find the complementary function. If the roots are real and not equal, then the complementary function equals to C1 e power m1x plus C2 e power m2x. And if the roots are real and equal, then complementary function equals to C1x plus C2 e power m1x. And if the roots are imaginary, then complementary function is e power alpha x C1 cos beta x plus C2 sin beta x. If the roots are imaginary and equal, then complementary function equals to e power alpha x C1x plus C2 cos beta x plus C3x plus C4 sin beta x. So with this the knowledge, I will solve some problems related to linear differential equations. Solve d square x by dt square plus 5 dx by dt plus 6x equals to 0. To solve this equation, first, so write the given equation in its symbolic form. So what is the symbolic form? D square by dt square can be written as d square. So d square x plus 5 dx plus 6x equals to 0, or d square plus 5d plus 6x equals to 0. So this is the symbolic form. Then write its auxiliary equation. So what is auxiliary equation? D square plus 5d plus 6 equals to 0. So this is the auxiliary equation. Now find the roots of the equation. So the roots are d square plus 5d can be written as 3d plus 2d plus 6 equals to 0. So d, common d, so d plus 3 plus 2 is common here, d plus 3 equals to 0, or d plus 2 and d plus 3 equals to 0. Therefore the roots are d equals to minus 2 and minus 3. So the roots are real and not equal. So the complete solution is complementary function only, because there is no q term, so there is no particular integral. So complete solution the solution equals to c1 e power m1x. What is m1 here? Minus 2. So minus 2x plus c2 e power m2x. m2 is minus 3. So minus 3x. So this is the solution. And the next problem, solve d square by dt square plus 6 dx by dt plus 9x equals to 0. So the first step is, first write down the given equation in its symbolic form. So this is d square x plus 6 dx plus 9x equals to 0, or d square plus 6d plus 9 into x equals to 0. This is a symbolic form, and its auxiliary equation is d square plus 6d plus 9 equals to 0. Then find the roots. So d square, so this is a square plus 2ab plus b square. So a plus b whole square formula. So a plus b, d plus 3 whole square equals to 0. So the roots are minus 3 and minus 3. So here the roots are real and equal. So if the roots are real and equal, then the complete solution is c1 e power, c1x plus c2 e power m1x. So c1x plus c2 e power m is minus 3. So minus 3x. So this is the solution.
If you feel this video is informative, please like, share and subscribe my channel. Click the bell icon for quick updates.